Hello everybody and welcome back. We're taking a look at question number 2 on the 2002 Euclid math competition. Okay, hopefully you've clicked the link in the description, either in this video or the previous one where we did question number 1, and got a copy of the contest for yourself. And you can try the contest for yourself. It takes you to the CEMC website and you get all their past contests as well as their solutions for them. And then you can try them and go through their solutions or come back here and see my solutions. And as I say, we're going through question number 2. Question 2 is a 3-parter. It's got 2 light bulbs and then a written part. What have we got going on here? A, the quadratic equation x squared minus 3x plus 4 equals 0 has x equals 4 as one of its roots. So what does it mean to be a root? If I plug in x equals 4, then this equation should be satisfied. It should equal 0. And we're asked, what is the second root? Okay. So there's a couple ways we could try and do this one. If you're very familiar with how roots of quadratic equations go, and I'll just briefly touch on this and then I'll do it the way I think most people will do. If you are familiar with roots, you know that you can write a quadratic equation as x minus root 1 times x minus root 2 equals 0. And when we expand this out, we get x squared and then minus root 1 plus root 2 x plus root 1 root 2 equals 0. If I were to match that up with the given equation, I think it's x squared minus 3x plus c. I don't need to figure out c. I'm asked for the other root. I know one of my roots is 4. So matching these up, I know 3 is going to be equal to root 1 plus root 2. So that's going to be 4 plus the second root. And I can work this out and say, well, negative 1 should be the second root. And I could say that if I wanted to. And so that makes this question actually very simple. We don't need to work out what c is. Now let's do it another way and confirm that, yeah, it is going to be a root of negative 1, just to make sure I haven't done anything silly here. So we can do it that way, or we know that as a root, we can plug in the value of 4. We'll get 4 squared minus 3 times 4 plus c is equal to 0. Well, what does this actually work out to be? 4 squared is 16, minus 3 times 4 is 12, plus c equals 0. That's going to be 4 plus c is equal to 0. So c is going to be negative 4. And that just lends more credence here, because 4 times negative 1 is negative 4. But now that we have our full equation, you can do whatever you like. You can factor it if you're very comfortable factoring things. You'll get x minus 4, x plus 1, and so you'll know negative 1 is the other root. Or you could do the quadratic formula at this point and say, well, my 2 roots are going to have to be negative b plus or minus the square root of b squared, 9, minus 4ac. 4, negative 4 here, and then 1, all over 2. That's going to be 3 plus or minus, this will be 9 plus 16, all over 2. That's going to be 3 plus or minus square root of 25, all over 2. So that's 3 plus or minus 5, all over 2. And that's going to be 8 over 2, which is 4, or negative 1. And then that'll have to be the other root. So there's lots of different ways we could have done this one. If you are familiar with how roots work and combine to give you your quadratic equation, you could have gotten negative 1 fairly quickly without even solving for c, just looking at that minus 3, that was enough. Or we could have plugged in 4, got the value of c, and then used whatever method we like to find the other roots. Factoring, if we're really good at factoring, or using the quadratic formula, which always works, always gives us both roots. So either way, we have minus 1 as the other root. And that does it for A. Now how about b? It's another just give me a final answer type question. The rational expression 2x squared plus 1 over x squared minus 3 may be written as 2 plus a over x squared minus 3, where a is an integer. What is the value of a? Okay, so if we have one expression that can be written as another, that's another way of saying these two expressions are equal. So we're going to keep our a in there, and we're just going to set these two equal. Okay? So it's 2x squared, I think it was minus 1, and then x squared minus 3. 2 plus a over x squared minus 3. Let's just double check that before we move on. 2x squared plus 1, actually, my mistake. So these have to be equal. Okay. Well, I've got this a over here. I'd really like to get him sort of all alone. So one thing I might do is I might subtract 2 on both sides. That brings the 2 over here as a minus 2. X squared minus 3. Okay? Well, I'd like to get this a, again, by himself. So what I should probably do is, I've got a divided by x squared minus 3, divided by that expression. If I want a by himself, a good thing to do would be to multiply both sides by x squared minus 3. Okay, so we get x squared minus 3 over here on the left. 2x squared plus 1 all over x squared minus 3 minus 2. And we should get a right here. So now if we can just clean this up, hopefully all the x's will cancel out. That's what we would expect, because a is a single integer. It's not an expression. They didn't tell us that. They said a is an integer. So we'll know we've done everything right if we come out with a as an integer. If we work this down and we say, 3x plus 4, that equals a. We don't put that as our answer. We know that we've done something wrong. We don't put 4 as our answer either. If we have this expression is equal to a is supposed to be an integer. We don't get an integer, we've done something wrong, and we go back and check our work. We don't just give up and put what we've got. That is not how math works. So, I have this a over here. He's just going to stay there. And I can multiply x squared minus 3 by this. 2x squared plus 1 over x squared minus 3. And then minus, I'll do x squared minus 3 times 2 over here. So let's clean this up a bit. Those cancel out. And we're left with 2x squared plus 1. And then minus x squared times 2 is 2x squared. Then minus negative 3 times 2, so that's minus negative 6, that's just plus 6, is equal to a. And if we group our like terms together, we see, we've got a 2x squared and a 2x squared. They're going to cancel out. And 1 plus 6, that's 7. So a is equal to 7. Okay? So that's how it all worked out. And we did get an integer as our answer, so we know we're good. Now, that doesn't mean we haven't made an arithmetic error somewhere. We might have misplaced a plus or a minus sign or something like that. But we're going to stop looking because we do have the integer we want. If there's time left at the end of the contest, we can come back and double check these, and rederive them on a separate piece of paper and compare our answers. But for now, we got an integer. We're good. All right, C, the written part. The parabola y equals x squared minus 4x plus 3 is translated 5 units to the right. Okay? In this new position, the equation of the parabola is y equals x squared minus 14x plus d. Determine the value of d. All right. So, translated 5 units to the right. What does that look like? So I have my original parabola, maybe it looks a little something like this. If I translate him to the right by 5 units, everything moves over by 5 units. He doesn't get squished, he doesn't get scrunched up either way, he doesn't move up or down, he just gets moved over 5 units to the right. Okay? So how does that get represented in an actual expression? Well, to go from my new one to my old one, I would have to do, if this were x, then this would be x minus 5. Or if I had a point here at x, this new point here is x plus 5. Okay? So, if I want an equation in x for my new parabola, I can find it by substituting x minus 5 into my old parabola. What was my old parabola? Well, it was x squared, so we'll say x minus 5 squared. I think it was minus 4, but let's just double check. Minus 4. We see an x, so we write an x minus 5 instead, plus 3. That's our new equation. And it's not written exactly the way we want it. Right? We want it as x squared minus 14x plus d, because we want to just be able to read off that value of d. So what we're going to do is expand these guys out using the binomial theorem or FOIL, however you want to do it. X squared minus 10x plus 25. And here we have minus 4 times x, so minus 4x. Minus 4 times negative 5, that's plus 20, plus 3. So we only have 1x squared. We have minus 10x minus 4x, that's going to be minus 14x. And at this point, I know I've done my substitution correctly. Sometimes, some of you out there might have problems with spatial reasoning, and you might know, oh, I need to add 5 or subtract 5 because I'm translating, but I just can't quite work it out. So you could have tried x minus 5, that's what we did, and that worked out. Or you could have done x plus 5. And if you had done x plus 5, you would have expanded it out, and you would have brought it all the way down here, and you would have gotten x squared, but you wouldn't have gotten minus 14x. So the fact that we see a minus 14x here tells us we're on the right track. Okay? I'll show you what I mean. We'll just flip the page just for a moment. We'll come back to this. But suppose I couldn't remember, which way is it? Do I do x plus 5 or x minus 5? Which way am I translating? If I had subbed in x plus 5 into my equation, and expanded it out, I would have had x squared plus 10x plus 25 minus 4x minus 20 plus 3. That would have been x squared, and then 10x minus 4x. We would have had 6x. And at that point, we say, wait, this isn't the minus 14 that we need. Something has gone wrong. Our equation isn't matching up with their equation. Okay? So that's something we could have done. So I'll just clear that. If you want to, of course, you can rewind the video and take a look at that again. But the fact that I have this minus 14x tells me I'm on the right track. I made the right substitution. So now, 25 plus 20, that's 45, plus another 3, that's 48. And I wanted x squared minus 14x plus d. Well, here's our d value. D is equal to 48. And that's our final answer. All right. So that was question number 2. Join me in the next video for question number 3 on this Euclid paper. And I'll see you guys then.